Hi, in this video, we're gonna talk about the math of finance. And this section is section 3.6. We're gonna be working with two formulas. I have a screenshot of those two formulas. If you feel they're not clear, you can always refer to page 306. The bottom of the page has the two formulas for a better quality picture. So the math of finance would tell you if you put your money in a bank and you save that money and the bank offers interest for your money to grow, how could you find how much your money will be, which is A, and A would be the final amount. You'll be interested to know how much you will have in 2 years, in 3 years, in 10 years. That's if you're saving your money in a bank. We're going to see words important like interest, and the new word to you could be compounded. And what we mean by compounded K times a year, this bank calculates your interest how many times a year. And this is what we're going to see in the sample problems. Now, the two formulas we're going to be working with, A equals P, parentheses 1 plus R over K to the power of KT. And that's if you can't see it clearly. Or A equals PERT, PE to the power of RT. And the difference between those two are those keywords. If I see the word interest compounded continuously, which means the bank is continuously calculating the interest on your money, we are using the second equation. If we see anything other than continuously, then we're using the top equation. And let's take a look at a sample problem. This is pretty easy and straightforward application of the formula. The most important part is to annotate, because those word problems, if you understand what is each variable and where does it go, you can solve it easily. Sample problem 1, find the amount accumulated, which means the amount is growing little by little after investing a principal of 10,000. So I know I have P for 5 years, so I know this is T at an interest rate of 7%, and I know this is R, and R always have to be in decimal in the equation. Compounded quarterly, quarters, that means 4 times a year. So all what I have to do is plug in each variable and each given for the variable. 10,000 for the principal, 1 plus the R 0.07 divided by K, and to the power of kt, so 4 times and 5 years. If I put this into the calculator, I'm gonna get this value, which is approximately $14,148. So if I leave my $10,000 in the bank for 5 years and they offer me interest compounded quarterly 4 times a year, I'm going to end up with 14,148. Always think about the final answer. It has to make sense to you. Other values of K could be 1 if the word problem says annually, which means once a year. If the word problem says monthly, it will be 12. And everything else, it will just say like 6 times a year, 3 times a year, and so on. Now, if I see the word again continuously, it means I'm using the second equation. So A equal PERT, principal amount, E, which is Euler's number, we find it on any scientific calculator, to the power of RT, and R is the rate, T is the time. If I put that in the calculator, I'm gonna get this amount, 14,000 almost and $191. So I can tell the difference and that I will make more money if I choose the offer from the bank that has the interest compounded continuously. Another way or another variable that could be asked in a word problem is how long will it take for your money to grow to a certain amount. So if I read this, I'm investing 10,000, it's still the same problem, same principle, same rate, compounded monthly, which means my K is 12, How long, so the time is unknown, will it take for your balance to be 25,000, and that's the final amount. So 25,000 will equal, I'm using the top equation because it doesn't say compounded continuously. The R is 0.07, the K is 12, and T is the unknown. We previously said when we don't want to solve for a variable and the variable is an exponent, if we want to solve algebraically, we must log on each side. So first of all, I want to get rid of this because it will just make my life simple. And this will turn into a 2.5. I can do this quantity on the calculator and you're going to get 1.005, I believe. And now I can log on each side. And this allows me to bring the exponent down. So will be log of 2.5 equals 12t log of 1.005. So remember, I am solving for t, so I want to divide by anything next to the variable. So I will be dividing by 12 log of 1.005 on both sides, 12 log of 1.005 on both sides, and the calculator will give me the value of t, and I'm going to leave this up to you. You're going to do it now and share with me. You always have to remember that anytime you want to solve an equation, you can solve by graphing. So another option will be to graph y equals 2.5 if I take the equation from here before logging both sides. And I can graph 1.005 to the power of 12t, and I can look for intersection, and that would be also a nice way to check my answer. So this is solved by graphing, and this way is solved algebraically, and you can compare.